Now let's learn how to differentiate the natural logarithm. Remember, the natural logarithm is the inverse function to the exponential function. So we can write the relationship that x is equal to the exponential function of the natural logarithm of x. The natural logarithm only takes arguments that are positive, so here we have to restrict x to be greater than 0. So we can use this equation now to determine the derivative of the natural logarithm. We're going to use something that's called implicit differentiation. Differentiation. What that means is we're not going to take the derivative of the logarithm directly, but we're going to take the derivative of both sides of this equation and then solve for the derivative of the logarithm. So instead of doing an explicit derivative of the logarithm, we're doing implicit differentiation. So if we take the derivative of x is equal to 1. The derivative of the exponential function is the exponential function. We have to apply the chain rule here. So it's the derivative of the outside times the derivative of the inside. So the derivative of the outside is just the exponential function again of the same argument times the derivative of the inside. And here is the implicit bit. So it's d dx of log x. This is what we want to determine. So the exponential function of the log of x is just equal to x. So we can solve now for d dx log x. This is x. We can divide through by x. So we get this result, d dx of log x is exactly equal to 1 over x. And that would be valid for positive x. A very nice result, right? Very simple. The derivative of the natural logarithm of x is equal to 1 over x. That is actually a very welcome result because we've derived the power rule before. Let me just show you that. So the power rule said that the derivative of x to the n is equal to n times x to the n minus 1. If we wanted to get 1 over x here, then n would have to be 0. But it doesn't work for 0 because the derivative of x to the 0, x to the 0 is just 1, is a constant, is equal to 0. So you cannot get 1 over x from the power rule. So it's very nice that we discovered that we now get 1 over x from the logarithm. Okay, we can generalize this a little bit. We can see what happens when x is negative. So if x is less than 0, then we can look at the derivative of the log of a positive argument, which here would have to be negative x. We know what the derivative of log is now, and we can apply the chain rule here. So this is equal to 1 divided by negative x, right, times the derivative of the inside, which is the derivative of minus x, is negative 1. So putting this together then, this is again equal to 1 over x. Okay, so when x is positive, the derivative of log x is 1 over x. And when x is negative, the derivative of log negative x is also 1 over x. What that means is that we can combine that. So the derivative with respect to x of the log of the absolute value of x is equal to 1 over x. And the only restriction here is that x cannot be equal to 0. So it can be both positive and negative. So if x was positive, the derivative would be positive. If x was negative, the derivative would be negative. We can see that by drawing a graph of this function. So let's have a look. So this is x, this is y. If we look at the graph of log of the absolute value of x, if x is positive, then it looks like the log, which looks like this. On the other hand, if x is negative, this would be positive, but it would correspond in the negative x-axis, and it would just be a reflection about the y-axis. So it would look something like this. So this is a graph of y equals the natural logarithm of the absolute value of x. So the only point that is undefined would be exactly at x equals 0. So we see here that the derivative is negative when x is negative because we're sloping downwards, and the derivative is positive when x is positive because we're sloping upward. So let's review. The main point here is that, or the main result here, is that the derivative of the logarithm of the absolute value of x is equal to 1 over x. So if x is positive, then you can drop the absolute value sign. If x is negative, then you require the absolute value sign. I'm Jeff Chasnow. Thanks for watching, and I'll see you in the next video.